Okay, welcome back to the Audiokinetic Theater for our final speaker for GDC this year. Someone I got to know a bit more this week, seeing him every day, Kristian from IO Interactive, will be introducing us to haptic designs and workflow, expanding our minds on how should we think about haptics. So Kristian, please take us away.
Awesome. Thanks for that presentation. Thank you. So first off, before I start, I just want to hear like a raise of hands for the people who vaguely know what haptics are, but not know more than that. So, okay, cool. So yeah, hello and welcome. Today it's going to be a little bit of a combination of my GDC talk. And then after that, that's going to be a choice. So I'll come back to the choice when you know what you can choose between and why it makes sense, right? So first off, let's talk about the philosophy of vibrations and how they work, how vibration design has been made historically, and then what audio-driven haptics even mean. I am Kristian Rømer. I am a senior sound designer at IO Interactive. I have a master's in game design, which I think is important because that's my sort of unique perspective to why we should be doing this in a collaboration. And then I was at GDC for a few years ago, and now I just did this talk. So my interest in haptics started back in the late 2020 when we were shipping Hitman III, and a few months before that, we got access to the PlayStation 5 development kits, and me and Klaus Byggersen had a brief exploration into how can we translate these old rumbles into audio-driven haptics. Then a year later, I did a cool explorations with another game designer, Antonin, trying to figure out how can we collaborate in a meaningful way without, having these long processes that we usually have when we are designing haptics. And then lastly, just a shout out to Mark Hasselbalch, a great junior sound designer who is really exploring a lot of the possibility space of how we as sound designers can express ourselves and work. So we did an exploration as well. So first, let's talk a little bit about the philosophy of vibrations and how they actually work. So we all know the feeling of receiving a text message or getting a call, and we immediately, just from the vibration in our pocket, can tell if it's a text message, if it's an email, or if it's a phone call. And that's because we are tuned into understanding our physical, digital devices using these tactile expressions. So it's very much a great functional tool to inform the users. And what is even more interesting is that we're actually using the same areas of our brain to understand the vibrations as we are when we are perceiving audio. So in a way, it's sort of an extension of our auditory perception. And as you can see from this graph from Sony, the human sensitivity towards vibration actually goes for, if you go over like 400 to 500 hertz with a vibration in your hand, we actually start to hear the vibration, even though it's physically happening as a motion. Yeah. So I believe that haptics can be used for more than functional feedback. And I want to just show two, let's say, rather abstract examples of vibrations that, for me, create emotional response. So the first one is one of our cats back home. It's purring, and this creates an oscillation on like around 47 hertz, and that vibration is relaxing and soothing. And the second one is thunder in the distance, and you can imagine a thunder or maybe an earthquake is more relevant over here, that you can really feel something is happening, right? And it creates an ominous feeling or something unpleasant about to happen. So we're already much more relaxed, right, in this space, yeah, totally. And then the second one's just thunder. Okay, so going on the leap that you trust me now, we can do functional and emotional haptics. Let's jump into the more nitty-gritty details. So we can use haptics to sort of communicate the overall experience design on both a functional and emotional level, with direct haptics that we observe, like getting a feedback that you're unlocking your phone successfully, or subconsciously using the same tools as we do with audio and music. Haptics have traditionally been designed by either programmers or game designers and been very much focused, or haptics, sorry, vibrations, been focused on informing the users of their action, enhancing the feel of different types of interactions you are doing, and they have historically also been very data-driven. So as you can see here, this is a great way to express your artistic expression. Just go in and tweak some values, right? Of course, game designers have been able to use different tools like animation graphs to sort of draw out their haptics or vibrations to make them more detailed and nuanced, like here in Wise Motion. But ultimately speaking, it's a rather crude output of using a target motor, left or right side, the duration of the vibration, and its intensity. So for me, that's sort of like when we're doing a level block out of a game. We as developers, we can see this and understand the possibility space and see how long it would take to get from A to B. As consumers, what we really want is, of course, the fully arted out version. We want to see that environmental lighting coming in, we want the textures, we want the ambience, we want the music. So I think audio-driven haptics can truly bring the same to vibration design. We should collaborate with our designers, and the reason this is the first part of this slide. When we're designing audio-driven haptics, we are going into a different field that we are not usually part of, and we should really take all the knowledge and expertise from our game designers and direction, who truly knows how the players will feel being in the world and when it's appropriate to do haptics. We can use it, of course, to express the tactile feelings that the game direction wants. So let's say you're doing a fighting game. Your haptics will be punchy and impactful and grand. But if you're doing an open world exploration, like imagine sliding down the sand dunes in Journey, those haptics shouldn't be punchy and like impactful. They should be subtle and beautiful, right? So I believe we can also use them to enhance the emotional intent of the scenes and, of course, maintain their functionality to communicate the game's intent. What is really interesting for us as sound designers is that we're going away from this data approach of punching in zeros and ones, but we're looking at a waveform. So it's not a target motor for us. It's about the spatial panning on either side of the controller. It is also not simply about duration and its intensity, but it's about amplitude and frequency division over time. And we can, of course, use our expertise as well as sound designers, because we have a huge vocabulary on how we express sound already. We know that a tonal or noisy signal will create one emotion. We can create soft and sharp interactions. We can create abstractions from the real world and what we already experience. But we can also be super concrete and make it one-to-one. And lastly, I believe we can also use this knowledge and our expertise to stylize the expression to fit within some very specific constraints. So I'll come back to that potentially if you choose that. And the last, not last, but a really important other thing to take into consideration is that we are actually talking about rotary motors and not speakers. So if you look at this beautiful illustration here, there's a sine wave that's going up and down. Looks great. And as sound designers, we can easily imagine what this sounds like. 2 sound waves. Great. So that works perfect on a speaker. You can understand it, you can hear it, can maybe even separate it in your brain, the two. But when you're dealing with a rotary motor, you have to imagine that there is like a constant moving of the first sine wave. And then we introduce a second sine wave. And what happens is the motor goes a little bit faster, a little bit slower, right? So the problem with that is we are combining multiple vibrations together. We are distorting the signal in a way. So if you want to create truly impactful vibrations, for instance, you need the motors to be completely still at the point of starting the vibration. And more so, you need it to replicate the vibrations the same across multiple instances. So in a way, for me, I have this long list of things we should be doing. Maybe we should be treating haptics as like a one voice to rule them all. We can only truly experience one vibration, at least on either side. We should think about the side chaining and the dynamic mix of how we can bring in different elements of the game. And then lastly, it's also really important that we consider fatigue, because we know that as sound designers, we cannot simply play white noise over the speakers for 10 minutes. People are going to exit. But it's really very much the same with the haptics, and it's actually even worse. So having even a relatively short duration of a pretty intense vibration signal will render the hands numb of the users. It's simply too much vibration for us. We're not used to that type of input. We're used to this crazy chaos of sound, but for vibrations, it's something that happens subtly usually and not that often. So here comes the choice. So the first topic here is going more into the actual design process of haptics, where the idea is that you guys can also feel a little bit on the controller, if that's possible. The second one is opening up more about the tools and workflows like Vibration Designer and how we can actually implement haptics. And the last is about haptics plus one, like accessibility and ownership, and hopefully a discussion with you guys on what should we do? Because I think the possibility space is really huge. So before you raise your hands or select something, I'm going to say that we have to select one of the boring topics first, so we actually can talk a little bit, and then we can get some hands on, no matter what you guys choose. So who is for tools and workflows? Who is for accessibility and ownership? That's great, almost middle down the line. I'm going to go with tools and workflows. I think that was mostly, and maybe we can get everything done in 15 minutes, I don't know. Jumping over all the fun stuff we did in Hitman 3, but we can go back to it. So when we are designing for specifically the DualSense controller, we can look again at this beautiful graph from Sony. And the thing is that's interesting here is that we actually have they call it a linear actuator, which sort of makes sense, but you can see a pretty big increase in feedback on the controller around these 60 hertz. It has stereo spatialization, meaning that the two sides are completely disjointed and can work independently, replicating the same type of signals. But what is truly a revolution as well for me is that it has the native audio input to vibration. So it means that in this example, I have a little toy synthesizer. It's hooked up with an audio jack into Reaper, and then that's outputted directly to the controller from Reaper, which is sort of the same setup that I have over here. And you would say, maybe, why is that interesting? Well, the thing is, we can now, as sound designers, sit and create our vibrations inside our favorite DAW. Of course, that's Reaper. And when we have designed these vibrations and played with them, and then we might get like an assignment. Let's say we're doing this sequence in a game where we are unlocking a lockpick or lockpicking a door. So before implementing this vibration and going into the lengthy process of getting a build, setting it over to the designer, saying, is this okay? No, that's shit. Okay. So then we can actually just render out a video of this sequence with the vibration data baked into it, send it over to the designers and say, try it on your PC, give me some feedback. This iteration loop, as you can of course tell, is much quicker than having to do it in engine. Of course, afterwards, we have to do it in engine. We have to take care of the mix and all that stuff. But anyway, I think this is just really, really a great game changer for us as designers. So, one of the tools. This is Vibration Designer, a Sony proprietary tool for the PlayStation 5. Basically, it's sort of like an old school audio editor. But what is really cool, as I've highlighted here, is that it does some extra things. So it has, for the people who are maybe not audio experts, it helps a lot because you can do an automated conversion. Because what makes sense as an audio file doesn't necessarily make sense as a controller vibration. Then we can do an AI translation. I don't know how that internally works, but it's cool. It creates some unique signals. And of course, we can also do all the normal editing that we're used to from any DAW. So it's just a great tool for you guys to know about. But another way, of course, of creating haptics is to use vibration recordings. So here, right next to me, there is actually a geophone tied onto a metal piece on a cabinet door thing. And what is really cool, and I'll show a little video, hopefully, on that, is that it actually is recording the vibrations happening on the surface of that microphone. It's a seismic recording microphone. And we can use that to actually record real-life vibrations and translate them over to our digital vibrations, which is really cool because imagine you're doing a sequence of a game where you have to reload or you have to interact in specific ways with physical object. Like we're jumping out of games, but like AR, for instance, imagine that you are making an AR experience where somebody has to learn about wielding a machine and dialing a knob. Well, let's record the actual vibrations happening on that knob and translate that down to the user so they can get a sensation of this is the wrong feeling, this is the right feeling. So if you feel this vibration in your hand, you're doing it wrong, right? I think it's just a great potential. Anyway, this is just me playing with a big stone with a metal piece, so I could tie in the microphone with a magnet. Yeah. So what I think is really cool is that going forward, we as sound designers can tell our Foley artist, hey, you are going to record this super cool Foley stuff. Could you just get a geophone in there or another type of recording microphone, like a seismic or a piezo microphone, or maybe even duct tape your dynamic microphone onto the physical object so we can get some of those vibration data, because it's just so beneficial for us on the other side having that. And again, what I think is just interesting is that we're actually recording vibrations as audio, and then we're putting it back as a vibration. So we can use all the tools, like we can pitch alter, we have to reduce noise, of course, and we can combine this vibration with a lot of other things. We can still be creative, we can still use synthesizers, right? When we are designing these vibrations, we of course can also combine it could be a middleware that's outputting the audio, and we could also still combine the engine's native rumble system down to the controller. So it's not a matter of excluding something that we already have. We can simply rely on expanding the fidelity we have with additional signals. So when we're implementing these haptics, it's basically the same approach as when we are implementing audio. So in the engine, you will take the gameplay event of something happening, an animation or whatever. We add an audio event, which is a haptic event. We can spatialize that over an emitter. So we can use the same spatialization parameters as we have used for audio. So imagine that you first have this shove you are playing here. This is you. You're Agent 47, and you're pushing somebody off a moving train. So we might want to spatialize that on the left side of the controller when we're getting the vibration data. But it could also be a chain wrangling on the metal surface over there. And that could feel super cool if you're close to it, but we definitely would like to implement the distance parameter on that as well. But could also be the train track. Underneath the train, the track's moving. So what we could do is we could also use obstruction or occlusion to alter how we are perceiving the world through the vibrations. DSP processing. So we can do whatever, filtering. Imagine that you get drugged. You can see a lot of weird cables going out his back, right? So maybe you're drugged and you are like disorientated. So let's add like a ton of reverb on all the haptics. And now what you're feeling in your hands is like a floating, weird, odd sensation, right? Enhancing the immersion and explaining the intent of the game. Of course, we can also use all the same gameplay data we already have. We know the player's health, so maybe we want to focus down on the functional haptics when you're low health and just remove all the rest. Super easy again, because we're using audio in the same way. Just to say, we are not excluding the rest of the team here. So this is, of course, a cool controller, but you can also do haptics and audio-driven haptics for other devices, like the Xbox controller. The step here in between is just that it's getting translated from, for instance, Wwise down to a controller data. So before you get to touch the controller, I'm just briefly gonna run over the design process. So we have 3 distinct modes of design. The first one is using a direct approach. That means we are basically taking the audio signal from the game, routing that directly to the controller, adding whatever processing we want. It's a super cool and very cheap way of designing. We get the exact timings from in-game, and we don't even need to do more audio implementation. We're simply relying on the audio to feed the haptics. Of course, it relies on a one-size-fits-all. So let's imagine you are doing the vibrations for all the Foley in the game. You want to add the little bit of additional thing. Well, some Foley sounds might work perfectly for vibrations, other will most definitely not. So. And also, we sort of lose control over the design process, of course. Second approach is the altered approach, which basically means that we are taking the existing game audio assets. Like this is some cinematic sequence. This is the audio file up here. Simply drag it into your DAW and clean it up. Make sure that only the vibration data you actually want there is in, and we get it back into the engine. So it's still based on the game's audio. We have the exact timings, but it's much cleaner. What I don't like about this approach is still we are limiting ourselves to the abstraction of whatever the game sound designers have created for the auditory experience. So, of course, we can use the bespoke approach. Here, we can use whatever, synthetic generation, traditional mic recording, and again, vibration recording. This allows us to create truly unique content that has a intention built into the recording process. We know what we want the player to feel on their hands when we are doing the material. And lastly, it's much easier for us to conform to a specific design direction. So imagine again you are doing haptics for this AR experience that I was talking about before. Then we might want to make sure that it feels in a specific way for whatever purposes. We, of course, have to spend time. And that's expensive. And we also risk that the audio designers have created this great, elaborate soundtrack, and with the vibration are just saying like, whatever, right? So we risk, of course, breaking the immersion for the player by detaching the two. When we were designing Hitman 3, we basically had a few weeks to do a port of 3 games onto audio-driven haptics. So we focused a lot on the systemics of the game, trying to figure out what can we bring out of the already existing systems. We selected bespoke in-world events that we wanted to highlight with vibrations. And lastly, we did a pass on the cinematics where it made sense. So I just have a few examples. The first one here is all the firearms in the game. So, of course, we went first with a direct approach because that was super cheap and fast. We just took the hits of all the gunfire sounds and we routed them to the controller. And that worked really cool for some weapons, and some of them it just was lackluster or weird. So we opted out to bespokely create the content. And I'm just going to play these 3 examples fast because you said you wanted hands-on. So yes, this is firing a pistol, which is like a punchy upwards movement, making it like a satisfying thing you can do a lot. Second one is a shotgun, which has still the punch in the start, but focuses much more on the rounded downwards movement in the wielding the large shotgun. Yeah. The last example is like a unique sniper rifle that you can find in Hitman 3 during gameplay and unlock. This we wanted to try and do something completely different. So we used a stereo haptic file where it starts clearly on one side and quickly jumps to the other and sums back to mono, which creates this jerky movement of the controller almost like railing out of your hands, which sort of makes sense if you're wielding like a super big sniper rifle, in my head at least. I haven't tried. Maybe I should. Yeah.
Also a bit like a slapback.
Yeah, sure. So I have a different example here of, sorry, the game is pretty wild, so to say. So you are strangling people as well. But first, of course, we try to take the Foley signal directly and route that over to the controller. But you will be able to hear sort of the transition from that to the more designed element in the last version. Yeah, so imagine like grabbing somebody and like starting the strangle here. The second one, we use the AI tools in Vibration Designer to modify the existing one. And in the last example here, we opted to dial that down and add synthetic hits on the specific moments throughout the animation where we really wanted the vibration to pop. So ultimately, the lesson is noisy signals are noisy. So if you have a controller that's just doing stuff, it's really hard for us to like perceive what it actually means and what we are supposed to interpret from it. And then the next example. So first I'll talk about the case that didn't go well. So in this level in Chongqing, China, there is it's beautiful and there's like a really detailed rain system where you have all the different surfaces emitting rain sounds when they're getting struck. So of course we also wanted the player to feel the rain on them. But after a lot of experimentation, designing different rain sounds, we ultimately had to just remove it completely. Because as I said earlier, when you have continuous vibrations, even soft vibrations, the players get numb in their hands and just uncomfortable and detaches from the experience. So instead, we opted to do a vibration on this train that is passing through the level at different places. And what is really cool is that even with just a little bit of vibration from the direct audio signal, it helped immerse the players into the physical space. Because as we all know, if some large object passes by us, like a train close by, you can actually feel that vibration. It creates this weird, much more deep immersion than we will just hear it passing by, right? Yeah, and maybe you guys could hear that. But I imagine that you're just feeling this slight tingling feeling of the vibration. And then the last quick example here is in a cinematic sequence where Agent 47 is walking up to this data core who is about to destroy all this this place. And we really wanted to make the feeling of this big metal flaps on the data core opening up, make it more immersive in a way. So this is an example of both a cinematic vibration, but also a highly abstract vibration, because in reality, standing on that bridge, you will not feel that physical movement, but it just adds to the tension of the sequence. Yeah.
It's all here.
Okay. So just to show you, I'll quickly show actually just the vibration. So imagine that we are taking the original audio source and we're translating that into a vibration. And I'll play it and explain why afterwards. Yeah. So anybody heard something they didn't expect?
The chirp.
The chirp, yeah. So what you said? Underwater, yeah. Sensation of being underwater. That's because we're actually rolling off all the high end, because the controller just makes that noise for us. But there's a chirp in the end. Like, how does that sound? It sounds super weird, right? It's like, woo. But the thing is, when we're designing vibrations, we really should close our ears and focus solely on what we're feeling in our hands. I'm not saying that a chirp is a great vibration, but what I found when going back and re-listening to some of these vibrations design is that they sound shit. I mean, it's just a bad sound. Like you had the sniper rifle clipping, like weird movement. It's not a good sound, but it's a good vibration. So thank you for coming and hearing me blab. Yeah.